Hi, you've got Nick Berry here from Seed Terminator. We're just looking at here how the Seed Terminator interfaces with the case driveline. So you've got the case, jack shaft, driveline attachment kit here, which makes the combine Seed Terminator ready. And this belt comes in that kit. And everything from here onwards is part of the Seed Terminator kit to suit the case machine. The features of this driveline is that we've got an overrun clutch built into this pulley. Now the really importance to that is that there's an actual brake in the driveline here on the chopper, and if we didn't have this overrun clutch, there would be a huge shock force that goes back through that driveline, and we've seen in the field clutches fail where some other systems that don't have this overrun clutch actually fail the internal brake on the gearbox. So an overrun clutch is critical on a case machine. We need this machine to run down smoothly so that we're not shocking that PTO gearbox. So what happens from there, you've got the clutch on the pulley, which just basically means that the pulley can stop and the gearbox can keep running, the mills can keep running down slowly. Then we have our German manufactured gearbox, which is highly precise. It's got spiral bevel gears, which are precision ground, and they don't create a lot of heat, so they're a highly efficient design. We change the direction to a vertical shaft, and then there's two belts that go to each mill. It's really important on the Seed Terminator driveline that we have independence with these mills. So there is a belt that goes to each individual one, and the reason is that if something hard goes through a mill, it can create a shock load in that driveline, and it may not be enough shock load to damage the mill itself, but if you have sensitive drive components that are rigidly connected to that mill, then you can destroy the driveline. So we have the gearbox, which is separated from each of those mills with a belt drive. So if there's some shock loading, there's no impact on the gearbox itself. It's isolated from that, and also there's no drive shaft between the two mills. So if there was a shock in one mill, it's not affecting the other. The drive line between them there is no drive line between them. There's no shock transfer between them. So we isolate the shock load from the gearbox and also from each individual mill. The other thing that we do is that we have the speed up of the belt drive isolate the speed from this gearbox. So this gearbox is running at 1580 RPM. And the mills are spinning at 2950. So we need the speed in the mills to create the amount of airflow and the suction, and also the capacity and the kill. But we want the gearbox to run slower so that it's not churning that oil up. If you've got high speeds, you've got a lot of oil churn, which is hot oil, which you would need to cool it then. Because this gearbox runs at 1580 RPM, because it's precision machined, it's highly efficient. It does not need a cooling system. So there is no cooling system in this gearbox. It is standalone. It's got its oil, and that's how it operates. With this configuration, there is some additional complexities to other ways of potentially driving the machinery. You've got the gearbox, you've got the two belt systems, but what that gives us is isolation from the drive, so there's no shock load going between the mills or to the gearbox to destroy driveline components. And you've also got additional functionality improvements because the horizontal rotation of the mills means that we can get a lot of material spread as far wide as possible. So having the horizontal orientation gives us the ability to provide energy to the chaff horizontally in maximum spread, so we can spread to the 40 feet. It also means that these mills are mounted like this, so we can actually access and remove them really easily. We can take these chutes off to bypass the mill. We can take these chutes off and replace the screens in 20 minutes. And we also get this maximum spread. So although there's some complexity to this driveline, there's features in this overrun clutch to protect the gearbox. There is isolation of the load path between the mills and to the gearbox. The gearbox is running slower for reduced heat. We've got maximum spread because of the horizontal orientation of the mills, and we've got the ability to take the mills on and off easily because of the horizontal orientation. Bypass on these machines is also simple with the simple removal of the chutes.